controller, we have decided to use a proportional resonant controller. This has less steady-state error and performs better harmonically compared to a PI controller. This controller is comprised of two different gains, proportional gain and resonant gain. Proportional gain directly affects present values, while resonant gain affects previous values of the controller. This controller is comprised of two inputs, reference signal and feedback signal. You subtract the feedback signal from the reference signal in order to generate an error signal. This error signal is sent to the controller, and the control signal that is outputted is sent straight to the pulse width modulator. For pulse width modulation, we have decided to use unipolar PWMs over bipolar PWMs. The difference between the two modulations, is that unipolar uses different reference signals for each commutation cells, while bipolar uses the same one for both commutation cells. As a result of unipolar switching harmonics are shifted to twice the switching frequency, which makes it easier for passive filters to filter out. In our inverter, for open loop, we used a generated sine wave using the math.h function, and in closed loop control, we used the output directly from the controller in order to generate our PWMs. So for the second order generalized integrator or SOGI and the PLL or phase lock loop, those two are often used for grid connection. Second order generalized integrator or SOGI uses the grid voltage and generates two orthogonal signals by introducing a 1/4 cycle delay to one of the signals. The phase lock loop takes these orthogonal values, performs a DQ transformation or Park transformation, and extracts the grid phase from the Q component. The grid phase will be used later to generate the reference current of the controller. Results and discussions. So, from testing the software, it was proved that it was implementing correctly and working as designed. The image to your left shows the sinusoidal PWM for all four switches, while to your right you have the purple sinusoidal signal, which is the voltage, and the blue sinusoidal signal, which is the current. Hardware components are individually tested and confirmed working. However, optimization problems in the gate driver circuit are still needed to be resolved in order for the inverter to fully operate. Thank you for listening.